Okay, guys, for this class I'm using two laptops. I will explain why. Because I need to explain and I need to be run the application also. So maybe I will switch between the Linux operating system and MacBook operating system. Just me connect my laptop and hello. Yeah, it's working. Hello. Yeah. So first let me share my screen. So So today we are going to discuss our a project which is the smile detection. So let me show the project first and okay. So project is inside this directory. I will explain and I will give you this all the code to you. So now I'm going to run my project. So running this application, I'm going to write this command actually and press enter because I am using MacBook right now, so maybe they are this time they are taking some time to run. But if you are using other system like Ubuntu or the Linux, they are deep learning code are more comfortable on that. Okay, so just 1 second. Okay, so right now you see my face. Okay, and in this case there something is appearing on the screen rectangle sign and there's some text is appearing on your like this. So here you see there is some label is indicating that I am smiling and I am not smiling. So this is the project. Basically this project is detect my face and also detect that I am smiling or not. So let's see. Right now this face is not looks like a smiling face, but when I try to smile like this, so here you see this just like yeah. So this looks like a smiling face, and yeah, I am smiling right now. So this project is detecting my face and also labeling that I am smiling. Okay, this project I am going to discuss in this today's class. Okay, if you understand this project, you can understand multiple project. It almost similar to the digit recognition project, but there's some differences I'm going to discuss in this class. Okay, the code are almost same. If you comparing this code with the last code, this almost same. They have also like train.py, test.py and something like that. Okay, something like that. So basically this is a very beautiful project, and I after learning this project you will create multiple projects which is similar to this. Okay, so I will explain everything about this project. What is the data set I am going to use, why, which type of model, it is a deep learning model or not, and if it is deep learning model, which model I am going to use, and multiple things I am going to discuss in this classroom. So it is very beautiful project I am going to discuss. So let me open my one notebook, and one notebook I'm going to write because I need to be explain this project first. How we create this type of application. So because I need to be terminate this application because the multiple thing is going on the same time. So okay, so it is terminated. Now let me open this one notebook and I'm going to explain. Okay. In the last class you have seen you have created a digit recognition. Basically most of the time all the CSS or all the image related project is almost same. Only some difficulty or say some code is increases in some project. So in the last class you have done a project called digit. I guess most of the people already know it is the last project and you understand very well in my last class. Today we are going to discuss this project uses what? This project uses neural network. I mean, this project is a deep learning project, and also this project is related to the image, where I am going to use image which image is very popular, where I'm going to use Amin's dataset, IST dataset. This dataset contain multiple images, and every images contain a handwritten digit like 9 or 7, and this image size is 28 cross 28. Why I'm telling about this image size? Because this 28 cross 28 image size, guys, is going to be used as a input layer. So if you remember this project in my last classroom, this is your layer, input layer. There's some more layer we are going to add, and so on. And at the end you will return 10 neuron as a output. 10 neuron. Okay, why I'm using 10 neuron? Because I suppose I'm using transformation, means 0 is supposed to be a vector containing 1 and 9 0. 1 is equal to 0, 1 and 0 0 up to 9 times. 2 is equal to 0 0 1 and so. Okay, and same this 10 neuron is nothing. 10 neuron is this. So you know this is the 10 neuron you can do add, because your output is 10 times your output has 10 values, 0 1 2 3 4 5 6 7 8 9. That's why you are ending with 10 neuron. Okay, but guys, and also input is 28 cross 28, because my image size is 28 cross 28. So guys, before jumping this application which I'm going to discuss is a smile detection, tell me guys, you are understanding this input layer and output layer for digit recognition project? Yes or no? Please tell me yes or no, that if you understand this project. I'm talking about the digit recognition project which I discussed in my last class, where input layer containing the 28 cross 28 value, and output layer containing 10 neuron, because I want to be vector, and vector is going to transform like this. If not, if you are difficult to understand these things, please let me know. Hello. Are you able to understand this digit recognition project which I discussed in my last classroom? Why I am using input layer is 28 cross by 28? So say yes or no. If you're telling no, I will try to be repeat again. Otherwise, go with the other project. Path, Akanksha, Himanshu, Mohan, Reski. Sorry for your 28 pixel, na? Yes. That's why every pixel has value, na? So that's why input layer is 28 cross 28 of the last project. It is clear for you? Now come to this project, second project which I am going to discuss. This project is called face smile detection. So face smile detection is a project where I am going to put an image of a face of a person in a neural network, and then your output is a single neuron, and output is like either 0 or 1, okay. If you are going to be returning, so you can also return two neuron, not single neuron. If you are getting 0, you can be indicating 1, 0 is meaning 0, 1 is meaning 0 or 1. So here you see this is simple application, looks like a very simple application, like just passing an image and you passing through neural network. Neural network output is either 0 or 2 neuron. Okay, this is simple. But the problem is, what is the problem? Because in the last project, image size is too small, which only 28 cross 28. But in the real scenario, we'll pass an image, and generally, if you are using very low level of image, whose dimension is 1000 cross 1000, suppose. So means if you are using 1000 cross 1000 image as an input for any neural network, Means for this, for 28 cross 28 image, your input will be like 28 times 28, and it is something like I don't know, let me calculate it, around 784. Means you are going to use input neuron is 784. But if you are going with 1000 cross 1000, you will get tens, 100, 1000, 10,000, 100,000 million. Means you are going to use 1 million neuron as an input layer, and it's not good, guys. Means deep learning is good. They are capable to be create a classifier for this image, but 1 million neuron as an input layer, it is not a good idea. So that's why other type of neural network come to the picture. That is called CNN. How many people know about this neural network? The CNN. It is called convolutional neural network. It is not a simple neural network, but it's called convolutional neural network. How many people know this name and even this classroom who already know the CNN? I'm not talking about the you know everything about the CNN, but you heard about the CNN in any time in your past years? Anyone in this classroom who have any idea what is CNN? So CNN is a special type of neural network. Okay, in the last class I'm using this neural network, simple neural network. Okay, it is called FNN. It's called FNN, fully connected neural network. FCNN means fully connected neural network. But this is called the CNN. First, let's understand why we need CNN. If we are going to create a project for this dimension image, 1000 cross 1000, it's not a good idea because input layer is got 1 million neuron. So that's why we have come to the CNN. So why the CNN? So CNN has a property, they will reduce the input. They will reduce the input by using two operations. One is called pooling, the second one is convolutional. So in the case of convolution, you will reduce the image size. Reduce the image size without altered feature. Feature means every image containing eye, nose, so it will not remove the feature, but it will reduce the image. Pooling is kind of reduce the image. These two operations we are going to use multiple times to reduce the input field, and it will reduce very good. Means you will reduce 1000 cross 1000 image by using some 2 to 3 step of CNN operation. They will reduce to maybe 24 or like 24 cross 24, or maybe like 50 cross 50. Okay, so or maybe like 100 cross 100. So after certain number of operation of CNN, they will reduce the image size. So now let me go to the code part. So if you go to training class, just 1 second. Actually, this project contain very like a stable code. Your model is here. So ignore the other Python code. We can touch. You can explain later. So think about this code. So forget about this code. Forget about this code. If you're talking about the digit recognition, you already seen this project. Flatten function, dense layer, activation function, dense, and softmax. Okay, you already see this project. So here you see, guys, this already seen. Yeah, this time this code is little bit different to the last code, but it's similar. Means first you will like use the flatten function, means convert to two dimensional image, convert to two dimensional array to one dimensional array. This function is this. Dense function means add 500 more neuron as an input. This is an activation function. Even you are going to pass ReLU as an activation function. Then you again neuron, and this is a number of 10, means you can pass 10 or 2. Right now you are using this model for what? You are using this model for a smile detection, so here output is 2. But if you are using this model for the digit recognition, your output should be 10. So first I am using a variable classes. Just one second. Okay, because I am using this model as used as a class, and yeah, this classes. Okay, why this not? So here you see this is a class. So you understand this code. This code is should be understandable because you understand this thing. Now I am going to explain this. Okay, this code and that code. So this is a two operation. This is a two operation. Add CNN layer 1, and this is another CNN layer 2, and this is a neural network layer 3 and neural network layer 4. Okay, here the number of neuron is 500. Here, sorry, it should be added. Okay, okay, this is layer number 4, and now, so here you see this is your code. First layer this. So now I am going to explain this code. Okay, now I am going to explain how this operation is reduce the image size. So let's understand this. So now, okay, so it is the meaning. Suppose your image is yeah, it's okay. Now it's okay. So listen, this first operation is doing what? So here, let me just 1 second. Let me zoom it. Otherwise, let me this part should be erased. Okay, anyway. So listen. Okay, now see. So first is called using the conventional using the filter. So suppose this is an image, and image has some number of pixels as a row and some number of pixels as a column. And here suppose I am going to write a number of like 4, 10. This is some pixel value: 12, 19, 102, 105, 108, 1116, 1117, and so on. And we are going to pass this image as a filter. Generally filter size could be anything, but not more than 5 or 6. So I am using a filter size 3x3. So this is your input image, maybe any dimension, n cross n dimension, and this is a filter. So what's the filter do? So filter will going to take this space first. So I'm going to use this different color. Going to take this space and use a convolutional operation. So suppose you will convolutional operation means it's called the convolutional operation. It's the meaning, if this is a 1, 2, 3, 4, and it's you like convolutional operation like oh sorry 4, 5, 6, 7. It is meaning you take the multiplication of this to get the multiplication of this, you will take the multiplication of this, and you will take the multiplication and create a single value like any 99. So same thing you will do. So it will go to this, take this space and this space, okay, and create a value. And this like this image should, after this operation, this image transform to the next step, and next step taking this dimension to this, okay, and then this, and then this, and then this, sorry, this, and then this. So it will be multiplied with the multiple times, and you will get different dimension of image. And suppose after this multiplication you will get 99. After this operation, you will get 102. After this operation is 103. So this image that, and then you will add call pulling. Pulling is another kind of operation. It is tell that 2 cross 2 pulling. It is a meaning. Suppose this is 99 102, so I am going to use different color, and 105 106. Suppose like that. So suppose I am going to pass pulling 2 cross 2. So I will take this image. Okay, I will take this image section and use max pulling. So it will what? It will using the maximum value of this. So suppose this is the image. After getting this, so you will get the value of 106, and suppose this all the operation is going to be this in this position. This is called 105 and 108 and 109. So after this operation, your image size will be decreases, but without disturbing the feature, because filter is this argument to check the every section of image and understand where is the eye, where is the nose, and so on. And this filter will transform to be reduce this image. Means you will starting this image could be like 1000 cross 1000, and you have to get the image maybe like 100 cross 100. And 100 cross 100 is much lesser than the 1000 cross 1000, and you can pass this image as a fully connected network, just getting to convert to a layer as a single vector, and it is like 106 105 108 and 109, and this is used as a input layer, and input layer passed to the network and output. Okay, so it will use, it will go to the less competition and better accuracy. So CNN will help us to use the chance to convert the high level of image, high scale level of image to convert to a low scale level of image without disturbing the features, and passes this image to the fully connected network. And you know what the fully connected network is do. Fully connected network simple as like other network, just using like fully connected network is like a normal network where I'm going to use ReLU function, where I'm going to use activation function of any like sigmoid or software function, and we get the output, something like that. So here you see this code. This code is got, it is added this single layer as a CNN layer. This is called a CNN layer. Where is filter 5 cross 5, and means how many filter I am going to use. I am going to use 20 filter. Most of the time use 20, 10, whatever you pass, it is okay. And the filter size is here 5 cross 5, and ignore this padding. Padding is not important right now. And input step is similar to how many input you are going to pass of the image, and activation function is ready. And pulling size is 2 cross 2, and a stride. What is the meaning of a stride? So a stride meaning is, okay, so suppose you are going to start with starting from this. So next, by default, next should be section is this. Next should be the section this as a max pulling. But suppose you are passing a stride of 2 cross 2. It is meaning after getting to this image, change to next, ignore this first and 2, and then take this. Ignore this and then this, and then ignore this and this, and take this. Ignore this and this, and take this. So it will what is the why I am going to use stride. The stride will stride has helping me to reduce the image like in a low dimension, more low dimension. So this is using the stride. So okay, this is the stride. Same layer we are going to be at, but after getting this max pulling and all, you will need, means after this 2 layer of CNN, your image is going to be down very low dimension. Now directly convert to this flatten and pass to the another 500 neuron and add the activation function. Now pass the last neuron, last layer, where this layer is dependent on the number of output, and adding the softmax as a activation function at the end. and now it is completed. I guess this is new, something like that, but this is a part of the course. That's why I'm explaining this. The convolutional neural network means convolutional means you have to means you have to be passes to means you have to convert to high dimensional image to low dimensional images, and this image could be good enough to passing through the neural network. If you didn't convert to high dimensional image to low dimensional image, your neural network is not capable to create a model which give the right accuracy, which given to right accuracy, because neural network is not capable, and also it will take too much time to be complete your training. Okay, too much time to complete your training, because there are millions of weight or millions of millions of weight means W will be created, and it is very difficult to manage this larger value of W. That's why we need to be used low scale level images, and it is very difficult to go to the low scale level images like by simple process. That's why you have to pass it through the CNN. So your exactly model is looks like in your project. This is the image, and this image is passing through a CNN layer 1, and again you have to pass CNN layer 2, and then you have to use neural network model, and that's your output. And this CNN containing two operations. One is calling what? Conventional operation, and second is like pulling operation. Same, and later you will get the logs. You're starting with 1000 cross 1000. After this operation, maybe you will getting the image of like maybe like 250, and 250 is enough. If the 250 is not enough, you add another CNN, and then you go to the NN, and this will be the output. And now come to the code, because I'm not going to write this code by line, because it will take too much time, or maybe you will get some error also during the code. That's why I'm sharing this code directly. So I'm not going to be any add more comment here, because maybe I will get error. I have forgot something like that. So now, so this is our model, and now training part. So training part is, if you understand what is the meaning of training. So in my first class, I have teach you machine learning follow this graph. Means your input or output decide the program. Yes sir, I know that. And you need a model. Right now you are using an NN model. Okay, NN model is means how many layer, how the output is looks like, this 2 output or 10 outputs. It is the meaning of model. Okay, so this is your model, input outputs. So this project called a smile detection. So a smile detection input is what? Input is an image, real image, and output is what? Single number. It is smile or not a smile. An image contains two type of image. Image should be containing two type of image: the smile faces or not smile faces. Because your model understand na कि this is the smile faces and this is not smile faces. So that's why I provide the data set in your code. If you go to the data set section, there is smile D. 0 is meaning all the smile or non-smile faces. Let me check this. Okay, if you see this image is a person face. I guess this is not a smiling faces. This all the image is not a smiling faces. Okay, all the image is not a smiling faces. Smiling faces है क्या मुझे? Just 1 second. I guess this is not a smiling faces. So you see this is a data set, and second folder containing all the non-smiling faces. Oh sorry, smiling faces. Here all the smiling faces is there. So that's why model can understand. So means data set has good, and we need to be label data set like input and output. So that's why I'm added this two folder. First folder containing label 0, which is all the input images, and label 1 containing all the like smiling faces like that. Okay, now this should be clear. Now come to the training code. So okay, because I like learn this all the stuff from somewhere, and that's why like my code style is not like a normal code. It is like it looks like a production code, but it is good. Okay, this is like it is a meaning that you can add like argument like indicating the data set and all during the training. So before training means this is the input of data input, and this is your label, same as the like same as this data and label is looks like same, which I discussed in my like project like into the deep learning into the deep learning class. Here this is a data and this is a label. Okay, means data containing all the images of like okay. So what, listen, I'm going to explain this first. So what I am going to do here, so images is look like a real image like JPG and PNG. Okay, and this images is containing in folder like 0 folder and 1 folder. So what I am using Python to process the data, because data processing is not part of the machine learning. It is the part of like machine learning engineer, but not like simple thing. So I am doing passing this image to a data process. Don't worry, I will explain this. I am also adding the data process code here. So what you do, it is process the data and convert a data containing all the images in a two area. First index of the array containing the image and second index containing non-string image. And here this image is not a JPG image. This is the NumPy array. And this is the NumPy array. How I do that? So I am creating a function called data processing. Simple. Oh, no data set loader actually. Just 1 second. Okay. So what I am doing? I create two variables. Single array like data and label. Data and label. Data containing all the pixel value of all the images and label containing the label value like smiling or not smiling. So what I am going to do here, I am using Python. This is a Python code. I am creating a for loop starting in the this directory. Okay, dataset directory. Okay, and dataset directory is under the smiley. Okay, so it will starting the loop, and first it will retrieve the image from this image path, and CV2 is a library called OpenCV library is helping me to read the image. If you passes this image, so you need to be, if you passes this path of this here, if you passes this image like any PNG image in the IAMRead function, it will read this image and convert to a number. IAMRead function which is getting the image from your source file and it will convert to the number. So let me okay let me explain some OpenCV. Okay, now I'm going to import CV2 means OpenCV. This is one library, is very pretty library. So suppose I'm going to use this function. Okay, I'm going to use this function. So let's see this function is working. So this function which need to be a path of the image. So I'm going to use this. I need the path of an image. Suppose I'm going to pass this image. Copy path and this. Okay, now see. If you print image, and I'm going to, let me clear. Okay, now I'm going to write python test.py. So see, the number is printed here. Number is printed. This number is nothing. This number is a image value, and you see every image convert to a because this image is a color image. Because this image is a color image. That's why. Sorry. That's why it's showing the color value RGB. Okay. So this is number means you are going to be take, and then we are going to pass this. Okay. So let me see. So I'm going to copy and paste. So now see, I will convert to color image to a gray image like BGR. So you see what will happen. And I'm getting every pixel value convert to a real single number like this. Okay. This is a way that you have to convert any grayscale image to the like black and white image. Okay. And now next line, this is the IITians library. Because don't worry guys, don't be confused. That's why this is a new library. Don't be confused. This is single library. This is single functionality. Maybe there's any function inside the CV2 is handle this type of things. But IITians is very prettier library which handling this like converting to this image size to be 28. Okay, something like that. So it is looking like that. And okay. By default, every image, so let me see what is happening. So go to the test and I'm going to add print one more part. I'm going to add image dot save. Okay. And I'm going to use this image. I don't know. Okay. I need to be import IITians. Just one second. Okay. Actually, I guess IITians convert. Just one second. 20 close 28. And oh, sorry, I didn't save this file actually. You see, means I will convert this image size to 28 plus 28 and something like that. Okay. So this is the operation you are going to do. Now, I guess if we didn't use this function image to array, let me think about that. Just one second. This image to array function is coming from the keras. So basically, this image is okay. This is a higher dimensional value. Like you see, the double dot is here. So that's why it is the function is converted to a single image like 28 plus 28. That's why it is using the second line of code. Okay. Now every image. Okay. Now see, because this is an image, because this all the operation is going for the single image, but you are running the for loop for entire image. That's why you are going to append this image to this data. Okay, you are going to append this image to data. Okay, now image is completed, means this operation for the single image. Now go to the same time to label. The label is getting from the path like either 0 or 1. You see, if there's a 0, if there is a 1, you have to add a smiling. If they're not, it is not a smiling, something like that. A simple you are going to add. And now you are getting the data and label. Right now you see every image has a very large value. So it is divided by the 255. And you know this is a numpy array. So it is divided to entire data. It is divided by the entire data, and you get the data and label is a low dimension between the 0 to 1. Okay, now what is the meaning of label encoder? What is the meaning of label encoder? It is simple. Right now, your image is 0 or 1 are there. Sorry. Right now, your folder is like 0 or 1 means this is a label. And if you party the label encoder, you will convert this 0 to 1 0, and this is the 0 1. Okay. This is the important because at the end you are going to return 2 neuron. Okay, 0 0, if 0 1 is coming, it is meaning of 1. If the 1 0 is coming, it is the meaning of 0. Okay, that's why it is doing that. It is the label encoder are going to that. Now everything is done. So now you get the image as a data. Train test split is a lump array, scalar. It is split the data in two parts. First is model we are going to add. Right now we are creating a model is separate file as class. That's why we are calling this class lanet directly. You see lanet from this folder, and you are going to be start the training, because lanet function is add a build function, not a fit function. If you are passing this name is fit, you have to use, oh sorry, it means if such build this neuron, so number of input is 28, number of column is 38 for the image, and diff is 1. You can ignore this diff path. Okay, number of class is 2. Class means either smiling or not smiling faces are there. Okay, that's why it's there. Even I didn't use diff anywhere in the train.py. So if you go to the diff, so if you ignore this diff, because I didn't use diff anywhere, if you ignore this code, this is a code for the like other format, so you can ignore this part. And now we are going to model.compile. So compile, because you are only two output, so I am using binary cross entropy instead of using a sparsal categorical cross entropy. I am using binary cross entropy because we have two value at the 0 or 1. Gradient descent I am going to add as optimizer, and accuracy you can add optional, either add or not add. Now start the training. Training need a fit function, train and test, and this is a part. Means you can use training and testing simultaneously using the TensorFlow. It is better. Means you can start training and testing simultaneously. If you ignore this, it will only train the model. But if you add this, it will start training and testing simultaneously. Number of ignore this batch size. I did not explain this batch size. The number in epoch is this 50 and so on. Verbose is means print every time. Means if you run this code, it will print the output every runtime. It is the meaning of verbose. So this part and this part is optional for better, but now and now, later everything is optional. Only this part is save part. Means you have to save this model in somewhere, and I am saving this model inside this lanet.py. lanet.py. Don't worry, I will explain what is the meaning of argx and so on, but let me just wait. So see, and it will be save this model in lanet.hdf5. This time I am going to use hdf5, not h5 model. And now this model is treated. So if you go to the project which I am going to share with you, just one second. Okay, so I have a project, just one second. Smile. Let me see. So in this project I explain everything, same project, the code and the repo. So if you run to this application, you see you have to create this virtual environment and so on. Keep installed. But if you start the training, so you have to write this code. It is the meaning that means suppose I am going to write this code. Basically I am not going to run this command because it will take some time to start the training. It is meaning you start the train.py, means you are going to run this file. Okay, and this file has this data set. So you have to mention the data set folder name. So that's why I mentioned this dot dataset smiley. So it is will be retrieving this, and also we have to mention the model where you want to save the model. So I want to save this model in this output folder and this name. That's why this, and same this model will be saved on that position like this. So that's why I'm using argnet model and so on. So this is the indication of that. So because I'm not going to start the training, because training takes time and maybe 2 minutes, 5 minutes, 20 minutes. But why I'm not running this command? Because it will use my RAM, and it is very difficult to start it is very difficult to take the class simultaneously. Okay, so something like that. But after the training, you will get a folder. You will get the folder lanet.5. Create a file, a training folder, and this is the training file. And now I'm going to running this application. I'm using one more file, detect.py. So now, what is the detect.py? So in this case I am going to open my webcam, and this is the code of OpenCV to starting the webcam. Now let's see how to run a webcam in the OpenCV. So I am going to comment this code and run this code. So you see, first you have to see import CV2 and you have to run this code. It will mean 0 means 0 is indicating for the web camera, and while means until jab tak there is no like q command I'm going to pass, it will be executed and you will have to be close the window. But without typing q, it will still open the window. So now I'm going to be write test.py and see what is happening. And it is start a web camera, and you see my face is appearing. My face is appearing. But you see the image is black and white. Why is showing the black and white? Because I am passing this image to the gray format. Okay. So now I am going to be select this and pass Q. It will be stop. And now I am going to be ignore this gray and pass frame. This value. Okay. And now see what is happening. This time my image is a color image and something like that. Okay, and you can see my face and everything in your classroom, and it is like that. So same again, I am using this code to start the web camera and getting my face value. Okay, now let me close this stuff. So this is the code. So I'm not going to use this code. Come to this part. So same this code is there, okay, but some more operation means convert the image size to this size. So I'm going to be, if you want to be use this AMLET, it will resize this image. So let me try. So I'm not going to try it. It will take some time. Convert to grayscale and so on. And now it is the important part. This part, okay, this part. So it is a mini, guys. What is the mini? This is a cascade file. Cascade file is a very popular file of OpenCV because your project to detect a smile. Your project is a project for detect a smile. But problem, suppose you pass an image with there is no person face. So it is very difficult to detect image, very difficult to detect a smile because don't know where is the face. Where is the face? So before detecting the smile, you have to have a face pixel. So we are not going to create any different neural network to detect the face, because there is already OpenCV provide a file called har cascade which help you to detect your face. And before passing through the detect your model, you have to pass it through the har cascade file. Okay, har cascade file. And har cascade file implementation is too easy. You have to use, just one second. Okay, there is one detector you have to add, har cascade. Right now har cascade part, just one second. Yes, this is a code, simple XML code, and we have to pass. Okay, just one second. Let me copy this code. Okay, it will take too much time. Just one second. Let me run this file. I ignore the training part. Just copy this system. It is a file for running the code. So now see what is happening. Just wait for some time. Okay, right now you see this face where this rectangle face is coming and the label is Amin. So go to the code part, guys. Here this is a detector in this image, okay, and you will pass the har cascade as a flag. They will detect the rectangular part of where your face is available. Your face is available means it will return. So if it will return it will return the position of face. So it will return the position of this, and also how many width long. Hello, Akanksha, your mic is open. Okay, means it will return the position of the face. Okay, it will return the position of the face, and we are using and okay, we are using this position and pass this and you put text on the screen and put a rectangular part on the screen with something like that. Suppose I am going to use different color 255. So the same color, let me, you have to quit this. Okay, now right now I'm changing the color of this. So let me run it again. Okay. Okay, right now this image, the rectangle is like a blue color. So that's why this color is depending upon in these two functions. Simple. So I'm using the green color only. So I'm going to pass this and passing this image. So because this is a label, okay, you know this is the face is getting, but you pass this face image, pass this face image as input for my model. So I'm going to control Z to be remove all the code. So right now the label is Amin, that's why it is showing Amin, but I'm going to make this dynamic. So just put this code. Yeah, so I guess everything. So now you see, you pass this image, RY is coming from this position, means your real image is gray and you're passing through means this is a numpy image starting from this number of row and taking the number of rows is there, and number of column is this and taking the number of column from this. That's why you're passing this image to this area ROI. Also you see the two value, not smiling and smiling, like 0 or 1. If a smiling is, if a smiling is greater than non-smiling, then you have to pass smiling as a label, otherwise not smiling, and you pass this frame is using the CV2 and so on, and you will complete the project. So now I'm going to run it again with adding this code where I'm going to put it. Make sure model should be loaded. Now I'm going to run. Okay, so not smiling. So listen carefully. When I try to be smile, it is saying that I am smiling, and I will try to be not smiling, something like that. So this is a project. Okay, so you can also create this type of project, this type of project. So how many similar project can be created like same code? So suppose you want to be created sleeping detection. Let me close this part, otherwise it will be take why it is not stopping. I don't know why it's not stopping. So now, so suppose you are going to be create a sleeping detection, means person is sleeping or not. So I'll guide you. You need a data set first. You can find data set you can get the data set from the internet. There lots of people are providing the data set for sleeping detection. It is hanging right now. You need a data set of two types. One is sleeping image and not sleeping image. Your model will create very easily. So same model you also use. Okay. Third, yeah, nothing. You have a model, you have a data set. Just start the training and you will get the code. Okay. But you need the HAR cascade to detect the eye. So don't worry. If you go to the HAR cascade, my laptop is hanging, right? That's why I'm not because multiple things is going on. My one notebook, my classroom, and the recording part. Just one second. I think your screen has been frozen. Just me. Yeah, I know this thing is happening. Yes. Are you able to get my screen, everyone? If you go to the hard cascade, is this I hard cascade as available here? See, so left eye hard cascade, lower body hard cascade, right eye hard cascade, a smile hard cascade. Yeah, they are providing also the smile hard cascade. Eyeglass hard cascade means you can detect the position of eyeglass, position of frontal face, position of like full body, position of like lower body or something like that. So you can use this hair cascade, but generally your eye hair cascade and face hair cascade is enough for doing any project. You can create the project which is similar to like a smile like sleeping detection. You can create this project like for age detection. Yeah, age detection is a little bit trickier, but you can create that. You can like create a gender detection. Gender detection is something like that. You have to create two type of gender, two type of image. One is male image, one is female image. You have to create the model for the both image. And guys, both the code are the same. Only you have to remove the data set and change the data set. Everything will same, and you will create this project very easily. So guys, I am going to share. Let me write code with you, and this is the project, and you are also getting the description where is the helping you to run this application, and I'm going to okay guys, so you have to get the project code from there, and you will download and you can